Thanks everybody for joining. I had a quick question for the audience real quick. How many of you describe yourselves as decision makers, whether that's executives or directors or people in leadership? Okay, and how many of you would say that you're a network engineer? Okay, any other roles out there that I'm missing for attending this one? Anybody want to, how about what you guys? Leadership position? Decision makers? Yeah. Well, the good news is that I've got Charlie Hagan here with me. He's my senior principal engineer, and he's been working on a lot of the SD-WAN designs that we've been deploying at Providence Health. And I'm Kellie Larkin. I'm vice president of technology in our engineering and operations group. Thank everybody for attending the session. All right. Are we a little early?
Yeah, like 1 minute.
Okay. Well, hope you guys are all having a good session. All right. Looks like it's time to get going. So I already introduced Charlie and myself. We'll go ahead and get to the disclaimer. I'm sure you've seen this a lot this week. And you've probably also seen this all week if you're an SD-WAN fan. All right, so let's talk a little bit about who Providence is. We're a Catholic not-for-profit healthcare system. We'll operate primarily in the Western United States. Our mission is to bring healthcare to the underserved. And what's really kind of interesting and unique about our enterprise is that we have locations in places like Seward, Alaska and Valdez, which are extremely remote, to rural, to suburban, and then also concentrated in dense metros like Seattle, Portland, and Los Angeles. So I wanted to, give a little bit of a history lesson about how Providence became an enterprise, because it kind of plays into the story about why we chose SD-WAN as a critical component of our infrastructure. And that's due to the fact that Providence grew by acquisition, and it literally became an enterprise via acquisition. And I think anybody that's ever gone through an acquisition could attest to the fact that they create a tremendous amount of tech debt, and especially in the networking world. So Charlie, you were here during that time period. Can you kind of elaborate a little bit on what some of those challenges ended up being?
Sure. So yeah, like with any acquisition, you have kind of a mishmash of circuits, hardware, routing types, anywhere from MPLS, point-to-point, internet, kind of mishmash together, oftentimes overlapping IP space, complex routing between old data centers and new data centers. So we really wanted to embark upon what at the time we thought was kind of a transformational journey. So what we decided to do was migrate to a single provider MPLS, standardize our routing domain, remediate some of the overlapping IP space.
Gotcha. Okay, so really you would call that a transformational WAN initiative at that time. So it did get us to a single network. I think that's really important to acknowledge.
Yep.
But I know that we had more issues.
Right. Yeah, it wasn't the panacea we thought it would be.
So let's talk about that a little bit. So one of the things that was difficult about the single national carrier was that very few of our locations were actually directly on their network, which meant for that project, all carrier services or most carrier services were delivered in a subcontracted model. And in an enterprise as large as ours, what we started to see was just a lot of inconsistencies in our expectations around SLAs, order fulfillment as an example, support for impairments. But where it really affected us the most was around diversity. So in our most critical locations, we ask carriers to build fully redundant circuits so that we can achieve the best SLA and uptime possible. What we found was that definition of diversity varied pretty greatly between those carriers, where they didn't understand exactly that they were creating single points of failure. That's why we like to work with those carriers directly to try to rectify those issues. So those are some gaps in this particular strategy that we really ran into using that single national carrier. Okay, let's shift gears a little bit. I think it's pretty obvious that we decided to embark on another WAN deployment, but we wanted to actually answer the fundamental question about, what does mission critical mean really at the end of the day? Is it as many nines as possible? Really, the question needs to be answered by kind of asking the business side, right? And your mileage may vary depending on what industry that you're in. But the business should be able to dictate what kind of downtime they can sustain while still maintaining operations. And of course, as everyone knows, the more nines you try to implement, the costs usually go up exponentially. So there's no reason to overbuild here if you don't need to. So it's a really important conversation to have. I would say on the second half of that equation is really about technical requirements. And I can give you the example that we have in healthcare is that we have a lot of legacy applications that do not tolerate network disruptions well. They were designed and developed to operate in a hospital, and now they're either running from cloud or on-premise data center. So we knew we needed an SD-WAN solution because we wanted to guarantee application delivery and experience as much as possible, even if the underlying transport was not, delivering pristine connectivity. So we took those requirements and we distilled them into, functional requirements that we were looking for in an SD-WAN vendor. And Charlie led the effort on the engineering around this and kind of walk us them through what we decided was really important to us.
Sure, yeah. So we were relatively new to SD-WAN technologies. We knew, like Kelly said, we wanted something that could kind of address the problems we still had with the single national carrier. So we brought together a few vendors. We created a big test plan. I'm not going to read everything on here, but things that ended up being the most important to us were things like dynamic path selection, zero-touch provisioning combined with automation capabilities. Right, we really wanted to be able to deploy sites quickly and with little human touch. Interoperability with our legacy network. We needed to be able to migrate hospitals while still having other hospitals on the same MPLS and have them be able to communicate with each other. And what was most important to us, like Kelly mentioned, we've got applications that can't handle latency or impairment very well. So we really wanted the platform to be able to detect impaired links and route around them as quickly as possible.
Yeah, I'd like to maybe go back just a little bit, talk a little bit about the testing that we did. So, we evaluated the market and had a short list of vendors and then narrowed that down to 3. And then we worked with a partner of ours to create a lab that looked very much like our topology. And in that lab, we actually, generated impairment traffic, and we really pushed all the platforms to see exactly how they would perform. And the link impairment detection remediation, to see it actually in action was very impressive. The ability to overcome impaired links on the Velo platform is actually truly unique in the industry from our evaluation of these vendors.
Right, yeah. I mean, everyone says they offer some kind of SD-WAN-like solution, but we quickly discovered that they're not all created equal.
Correct, right. So your mileage might vary, depending on your requirements and what you're attempting to accomplish. Another vendor's platform might be suitable for you. But for us, it really did come down to the fact that we had those very sensitive applications that really didn't respond well to impaired circuits and other challenges. Kind of walk us through the architecture a little bit, Charlie, about what's really important about what we have deployed.
Yeah, so the elegance of this solution over a traditional route switch environment is we can really take advantage of varying circuit types. Like you said earlier, we've got sites in remote Alaska and other locations where there's not a lot of infrastructure available from carriers. So in those instances, we can use whatever the best option is, whether that's cellular, satellite, something like Starlink, or just commodity-based internet.
Right, and in our business being, Catholic not-for-profit healthcare, we often, as I mentioned earlier, we try to bring healthcare to where the under-franchised are, and they're often economically disenfranchised, and those specific geographies always pose the most challenge in terms of getting quality connectivity and redundant connectivity. So sometimes we need to combine completely different transports. And what's nice about the platform is that from a logical perspective, they're all active and all treated the same at the same time. And the best path across any transport can be selected in real time. And that's really kind of what some of the magic about the platform that for us in healthcare, where we need to maintain that connectivity as much as possible, is really super important.
Yeah, the other important piece is via business policy, we know what our mission critical apps are, and we can steer those apps over whatever link is the most performant at the time. Well, maybe we have some applications that are less sensitive that can go over a less performant link.
Correct. Right. All right, so we've selected a SD-WAN vendor at this point. I'll let you guess what it is. But we wanted to also address the issues that we were having with the single national carrier. So what we decided to do was shift to more of a regional networking approach, where we were really looking for vendors that had a majority of our sites directly on their network. And that allowed us to negotiate directly with them. And most importantly, it allowed us to actually participate in the diversity design engineering for circuits. And that's really important to us. We have a standard that we follow, and this way we were insured and could contractually compel them to actually deliver the diversity in a very defined way. That's something we just really didn't have with our other single national carrier. So I know what you're thinking. We kind of had regional networks to begin with, and then we thought all our problems would be solved with a single enterprise-wide carrier MPLS, and now we're going back to regional networks. So, Charlie, what's the story here? What are we doing?
Yeah, crazy, right? That's really the elegance of the SD-WAN solution, right? In a traditional route switch environment, you have to manage all the routing, all the complex region-to-region connectivity, and with SD-WAN, you can kind of abstract that away from the transport, right? It doesn't matter what kind of link the traffic's on, it can still get from point A to point B. Obviously, moving away from a single national carrier,
Right.
Our sites were no longer able to communicate cross-region directly. So the other piece of this was we had to build a network to stitch all of those together.
Right.
What we decided on for that was to build a fully diverse, fully redundant 100 gig backbone, which is way more throughput than we had before. And I mean, our biggest flows and our most crucial flows are between our data centers.
Correct.
Right. Imaging uses a ton of data.
Right.
So we're now able to kind of open the pipes for that, transfer that faster, as well as kind of accelerate our migration to the cloud.
Yeah, so on our previous MPLS network, we were sort of capped at a max, maybe 10 gig.
Yeah, 10 to 20 gigs in the data center.
And we have a lot of replication jobs where we're obligated to store and retain medical records, images, and things like that. So we ended up with creating a ton of data in healthcare. And this backbone, we believe, is going to be a game changer for us because we can dedicate pipes to specific workloads like genomics research, where they need to pipeline massive amounts of data into Google for AI processing, things like that. We have some really unique use cases where, when we took a look at what we were building in this regional network design, that, we really wanted to have a high performant private backbone that we could actually control and have full visibility end to end. The other advantage to this is that there's enough cost savings moving away from MPLS. By regionalizing the networks, we got much better pricing and standard pricing because we negotiated as an enterprise in that market, and we contain that traffic on their network in almost all cases. So that allowed us to implement a lot of scale. So before, we were pretty much, our access and our port speed were the same. And that was at our smaller sites, which were internet-based, and VPN was 100 meg. That's our standard now, but at the time, it varied from 20 meg and 50 asymmetrical broadband to fiber, depending. And we standardize everything onto fiber with 100 meg port or 100 meg access and a 1 gig port. And that our hospitals, all circuits that are delivered is a mix of public and private, so we can do internet offload. And we also have 10x scale on those ports as well. So they're 1 gig access speed on a 10 gig port. That gets us a ton of flexibility in our network to be able to scale at the time the business wants to actually do something. And I'm not sure about what industry that you're in, but we get little to no advance warning that they want to put a 3D mammography machine in a remote clinic. And then, we're waiting 6 months to get a circuit installed. So this kind of alleviates that, future-proofs our network to a certain degree, and gives us enough bandwidth and scale that, if there was another merger and acquisition, all this bandwidth would likely come in very handy.
Yeah, I just want to reiterate, rather than being the bottleneck, we can now kind of think of our WAN as a strategic advantage.
Yes, yeah, right. And in healthcare, we do a ton of third-party connectivity. So a lot of times we'll actually resell our services to smaller healthcare entities who don't operate at enterprise scale. This design also helps us facilitate that because we center our WAN around WAN aggregation points, carrier hotels. That allows us nice meet-me point connections to allow all that third-party traffic to actually enter our network and go through our business partner firewall. And we actually use SD-WAN for that as well.
Sure do.
In that design, we actually, to the third party, which is often like a small clinical office or even a medium-sized doctor's office. And what we'll do is we'll actually send SD-WAN equipment out there, and they simply just have to get it on net, and then we drop configuration right with the orchestrator. So it's a zero touch on their end, and they never have IT staff. So our previous model was VPN. We spent a lot of time on the phone working with them and essentially acting as their IT outsourcer, even though we weren't actually being paid to do that. So this is a really elegant model for you have any third-party connectivity issues as well. All right, so really what was transformational about what we did with deploying SD-WAN was really doing both the SD-WAN deployment and the regional circuit design. That really provided better than the sum of its parts, because we were not only able to increase reliability, improve SLAs, and as much as possible streamline things like support, and most importantly, we have a say in design of diversity. Really was a game changer. But then to top it all off, we were able to realize a genuine amount of cost savings. About 30% of our circuit bill decreased while moving to this way more performant network. So I don't know about you guys, but not many times in your career that you get to be able to implement all this functionality and actually save money, right?
Right, better, faster, cheaper. Who wouldn't want that?
Exactly. Okay, I want to talk a little bit about something that we learned though, because when you deploy a highly orchestrated software-defined wide area network, you're in the software deployment business. And this is something where we quickly realized that we needed to group our sites into rings and limit our blast radius as we evaluate new software from the manufacturer plus our configuration. And this just helps us ensure that while the orchestrator is such a great asset in terms of being able to manage your entire deployment, it also can be a weapon of mass destruction if not used carefully. So our recommendation, if you're going to deploy a platform like this with this level of orchestration, is that you actually create this ringed methodology and stage and only deploy to those sites and let them burn in before you move on to the next ring. And the idea is that we start with our least impactful sites, office buildings that are open 8 to 5, that there's no medical care happening, and then we kind of stage our way out. And that's been really successful during the deployments, right, Charlie?
Yeah, and I mean, the other piece to this, there's always going to be bugs in any platform, right? So testing in the lab, testing in a lower stakes environment, and then gradually working your way up really helps kind of limit your blast radius.
Right. Okay, so we're going to wrap it up a little bit, but I kind of want to talk about, in summary, kind of what we learned along our way with the journey. And that's really, solid principles of any engineering effort is really understand your requirements. What are you designing to? What applications run in your environment? What are those expectations of application delivery over the WAN? And how much a network impairment can your applications tolerate? Those are very important things for us in healthcare because, like I said, we have legacy apps. The other thing is something as big of a project of this, if you're in the enterprise and especially in a critical environment, we often get a lot of pushback on making changes in the environment because the perception is that changes are the cause of downtime. So having executive buy-in about why you're actually deploying this technology, the mission critical kind of SLA construct that you're trying to achieve has material business value. Articulate that back to the business, get their buy-in, because they'll be your best advocates when it's time to deploy. If you can, of course, build an ROI model on cost savings, right? That helps justify the why of the project and actually, again, delivers that material business value back to the business. Obtain a dedicated orchestrator instance. This is, kind of common sense. You want to be able to control the orchestrator when it gets patched, when it gets updated, so it happens on your maintenance schedule and you're ready and prepared for that. As Charlie mentioned, bugs happen, and you need to test before you actually deploy, and do that in your lab and ensure that it is matched to your configuration. And one of the things that we do is we took our original test plan, and it's also part of our regular test harness prior to evaluating any software that we deploy. That helps us understand that, is there a regression bug in the scaling, right, that we observed? Does it still behave materially in the same way? And those are important things for us, obviously, because we're mission critical in healthcare. Ring deployment, just talk about that. That's something you're really gonna wanna do. Also, work with your OEM, your vendors, on doing bug scrubs, right? You wanna understand, is there bugs that they're encountering in a key feature that you deployed? You may not want to deploy that, that release until it's fixed. And then lastly, what we learned, and is actually a really strategic asset for us, is the Orchestrator API. I'm not sure how familiar people are with what that it can do for you in terms of orchestration and visibility, but all of that data is available via API. And as a matter of fact, we scrape all that data and we augment our dashboards, our tooling, our alerting. Our network operations uses it heavily to actually determine, is there impact in the environment? Because you get a lot of rich data about how well is the quality of experience of my network versus what the link or what the carrier is delivering as an experience. So that also helps us hold carriers accountable, right? We pay for SLAs, we pay for diversity, and when they don't honor that, now we have a system with which to pull data to prove that they did not deliver the service that they were being paid to deliver. And we use this data to actually hold carriers accountable to WAN performance standards in our contracts.
Right, I just want to add to that. So we're now in an environment where if a carrier has issues on one of their circuits, more often than not, our end users don't experience impact, right? The platform's good at routing around that, but we still need a way to hold our carriers accountable.
Right, and what you don't want to lose visibility of in this platform as well, does such a great job at remediating and routing around impairment. It also can obfuscate the actual underlying carrier network, right? And you want to make sure you hold them accountable to that. My experience is that it's not like the carrier network is going to magically remediate itself. So you could have a down circuit, you could be routing around it and not really know it. So use the Orchestrator API to get that data to understand that link is impaired or it's down, and generate a support request with your carrier to get that done. Because if they do have a fiber cut, right, and you have two circuits, one's down and you're not noticing it, then you're in a single point of failure. And that's, obviously being mission critical, that's the situation we want to avoid the most. All right. All right, Q&A time. If people have questions, please step on up to the microphone so everybody can hear you. It is being recorded. Anybody?
I'm Jake Horrible from the W Group. How do your engineers react to being asked to change how they manage the network? It sounds like you moved from a traditional CLI environment to something that's more graphical. What was the training like, and how did that go along for you?
Yeah, that's a really great question. So one of my biggest concerns kind of leading the engineering effort was we got a lot of engineers who come from a traditional Cisco route switch environment. They're really used to working in a CLI, like you said, and this is kind of a culture shift, right? We're moving from command line to mostly web user interface. What really worked to our advantage there, I mentioned the test plan and kind of the bake-off between the vendors. I brought all those engineers there with us to be a part of that. Them really seeing the capabilities of the platform, had them sold. You also asked about training. We worked with VMware to put together training. We had VMware involved in the initial deployment via professional services engagement, and kind of brought everyone together and got on the same page.
Yeah, it's a different environment, and I alluded to that in the software deployment model, right? The how you manage this environment, it fundamentally changes when you have the orchestrator. But again, the orchestrator is what allowed us to actually move to regional networks and to get off of MPLS, because we were able to manage it as really a single WAN entity, even though there's multiple carriers plugged into that. It's a great question. Thank you. I'll have to look up the W group. Okay, okay. Anybody else have any questions?
Just curious, how do you handle work from home users, not necessarily the radiologists and stuff? Because I think I heard earlier you might have devices, you ship them, but do you have software that loads on things, and how do people from home work?
Yeah, so we use it's not a VMware product. We use a different product for that for home users. They connect through the same carrier hotels where we talked about the circuit strategy with the backbone. So they enter the network there, go through the firewall there, and then are on our network.
So it back ends into it, but doesn't talk straight to it.
Correct.
Okay.
Yeah, but in the case of like our small partners, right? Which a big use case is radiology. We will ship SD-WAN devices to their location and manage them remotely, so that we don't have to rely on their IT.
But
Yeah, and once they're on our network, they are writing the SD-WAN fabric to get where they need to
Yes.
go. They're just not using SD-WAN to get onto our network to begin with.
Yeah.
so do you have radiologists, not necessarily part of other people, but part of your own, that have devices, or are they just using the VPN to come in and doing reading that way?
Yeah, we've piloted, having SD-WAN devices in people's homes. There's been a big shift in radiology where most of it is being outsourced. And so the work from home is getting a little bit less because all these big partners are kind of getting all the rads together in a single location. And so that's kind of where we plop in SD-WAN is there. But I mean, there are obviously, a lot of health systems are very different. This is just something we're experiencing in our business.
Thank you.
Oh, sure. Great question. Thank you. All right. Anyone else? Okay. All right. Going once. Going twice. All right. 3 times. Thank you very much for coming. Charlie and I will be hanging around if you want to chit chat or have any questions for us. Please take the survey. And then additionally,
Stay connected.
Yeah, stay connected, just like we said. And thank you very much.